Welcome to Unit 6, Day 1. And in this unit, we're going to be studying trigonometry. Today, we're going to have a quick review of the Pythagorean theorem. The Pythagorean theorem requires a right-angle triangle. So in this triangle here, we have three sides, A, B, and C. Generally, C is used to label the longest side or the hypotenuse. Now, the hypotenuse can be recognized by the fact that it is always right across from the 90-degree angle or the right angle. Okay, so C, the hypotenuse, the longest side right here. Now, the Pythagorean theorem says that the square of A plus the square of B will equal the square of C. Or in other words, A squared plus B squared equals C squared. Let's demonstrate this by using a number of tiles. We're going to represent the side with a unit of 3 with 3 tiles. Side 4 with 4 tiles, and the hypotenuse with 5 tiles. So if we consider what A squared plus B squared equals C squared actually means, we're going to create squares out of each one of these sides. 3 times 3 is the square of 3. 4 times 4 is the square of 4. And 5 times 5 is the square of 5. So to substitute these numbers, we would get the equation 3 squared plus 4 squared equals 5 squared. Now let's actually represent that area by filling in the rest of the squares. If we multiply our 3 squares by 3 squares, we get an area of 9. And by multiplying our 4 squares by 4 squares, or 4 tiles by 4 tiles, we get a square area of 16. And multiplying our tiles 5 by 5, we get a square with an area of 25. Now, if you counted all the tiles in this square, added all the tiles in this square, you would get the same number of tiles in this square, where literally the square from A plus the square from B equals the same number of tiles as the square of C. This is literally the Pythagorean theorem in practice. In this example, we're going to label each side. Again, C is always the hypotenuse, the longest side or the side directly across from the right angle. The other sides, doesn't really matter whether we call them A or B. We can put them in either order. Doesn't really make too much difference. So let's label each side, A, B, and C. Now we're going to substitute the values into the Pythagorean equation. You'll have to find one of A, B, or C. Well, we happen to know A and B, so we're going to be figuring out what C is in this case. Rearrange the equation. and then solve for the unknown side. So c squared equals 3 squared plus 5 squared gives us c squared equals 9 plus 25. C squared equals 35. Now, to figure out what the value of c is, we take the square root of c squared to give c. If we take the square root on one side, we have to take the square root on the other side, which gives us a final value of c, for c, with the square root of 34. c equals the square root of 34. Reducing that further with our calculator gives us a value of 5.8 for c. In this example, we can start by labeling our various sides, remembering that the hypotenuse is always going to be c. Substitute the values that we know into the equation. So we can say that 4 squared plus b squared equals 8 squared. The unknown is b, so we're going to isolate b. We'll take that b squared and we'll leave it on the left side of the equation. B squared equals 48. Therefore, b equals the square root of 48, giving us a final value of 6.9. Side b has a length of 6.9 centimeters. Now, in this example, we're asked for the length of side C for triangle 2. Right now, we don't have a lot of information about triangle 2. We know that side A has a length of 3, but we don't know what B is, and we don't know what C is. We need at least 2 sides to be able to use the Pythagorean theorem to figure out the other sides, or the last side. What we do know, though, is that triangle 1 and triangle 2 both share a side. And if we look at triangle 1, we can see that we have enough information to solve for the remaining side of triangle 1. Once we do that, we can use that common side B, which will give us 2 pieces of information for triangle 2. So let's start by solving for triangle 1. We're given A and C, so we can write an equation for triangle 1 by saying A squared plus B squared equals C squared. A is 5, so 5 squared plus B squared equals 7 squared. Isolating the B squared on one side, we get B squared equals 7 squared minus 5 squared, which gives us B squared equals 49 minus 25. B squared equals 24. Therefore, B equals the square root of 24, which happens to be 4.9. Now that we have a value for B, we can use that to help us solve triangle 2, because that B is a shared side, and now we have 2 lengths for triangle 2. So now we can write ourselves an equation. We've got for triangle 2, we've got enough information. So triangle 2, a squared plus b squared equals c squared. We sub in the values. 3 squared plus 4.9 squared equals c squared. C squared equals 3 squared plus 4.9 squared. We just switched the numbers around. We've just flipped the equation so that we have c squared on the left-hand side. C squared equals 9 plus 24.01. C squared equals 33.01. C therefore equals the square root of 33.01, which happens to be 5.7. Therefore, we can say side C, or X for triangle 2, has a length of 5.7 meters.